Now we can start looking at interpreting our velocity graphs. I'm going to start with a fairly simple one. It's a quick reminder again, positive velocities mean moving forward, negative velocities mean moving backwards. In this particular one, everything above the x-axis is this whole big chunk here, so you're moving forward that entire time. And down here below the axis is when you're moving backwards the entire time. If you're actually on the x-axis, that means you're not moving. So in this case, both at the very start and at 7 seconds, we were not moving. Now we can take a look at a few other things on our velocity versus time graph. So for example, these horizontal flat segments are where we've got constant velocity. Well, constant velocity also means no acceleration. So both of those segments have no acceleration on them. If I've got an upward slope, that means I've got positive acceleration. And if it's a flat line, it's a constant value for that acceleration over that whole straight segment. Now this one is also a positive acceleration, but it's a little bit steeper. So that particular segment has a little bit higher acceleration than our first segment did. If it slopes downwards, that means you have a negative acceleration. In this case, it's the steepest slope out of all of these, but it's a negative slope. So that means your acceleration is in the negative direction, and it's a fairly large negative acceleration. Now we can also look at the concept of where I'm moving further away from the axis. So both of these segments where I had a positive acceleration, I'm moving further away from the x-axis. And that means I'm speeding up. I started not moving, and as I go along in time, I'm moving faster and faster and faster because I'm further and further away from the x-axis. Now, any place where you're moving closer to the x-axis, that means you're slowing down for that segment. So I started with a fairly fast forward-moving velocity, and I came all the way down here to remember where I was not moving at all. So what about this chunk down here? Well, it's below the x-axis, but if you notice, I'm moving further and further away from the x-axis as I'm going. I'm moving backwards, but I'm also speeding up as I'm moving backwards because I'm further from the x-axis. So I started not moving, and then I started backing up faster and faster and faster as I go down. So you have to be careful when you think about acceleration versus speeding up and slowing down. They're not necessarily the same. This entire segment is a negative acceleration, but in this case I'm slowing down, and down here I'm speeding up. Now if you've got an actual curve for the velocity as opposed to straight line segments, we can still understand this in the same sort of way. Over here, I've got positive velocities, so this whole section I am moving forward. I start off speeding up, so I had no velocity and I'm speeding up faster and faster and faster, and then I start slowing down, but I'm still moving forward. Now, we don't have constant acceleration over this particular path because it's curved, but I can imagine my acceleration in terms of how steep it is. Now, once I get over here to this point, I've actually come to rest. But I don't stay rest. This isn't stopping and staying stopped. Instead, I'm changing direction because I was moving forward. Now I'm moving backward. And from that passing through rest as I change direction, I'm speeding up in the negative direction, getting faster and faster, moving backwards. And then I start slowing down, moving backwards. And again, I'm going to change position. So you can keep going through one of these velocity curves to figure out which direction you're moving, whether you're speeding up or slowing down, and if you've changed direction. So again, as a review, your positive and negative tells you which direction you're moving, forward or backward. Any horizontal sections are constant velocities. If you've got a straight slope, you've got a constant acceleration, with upward slopes being positive accelerations, downward slopes being negative accelerations. And you can figure out speeding up and slowing down in terms of your distance from the x-axis. Speeding up, you move further from the axis. Slowing down, you're moving closer to that axis. So this just gives you a bit of an overview for what to look for when you're interpreting those velocity graphs.